Okay, let's take a look at failing to see something that people should have saw coming, and that is Intel, risk versus CISC. What does that mean? So we're actually looking at a bunch of just different information here that's applicable in different ways. I think it's sad that we don't really talk about um, processors and what they do because they're so fundamental. It's kind of like, hey, the processor does this, let's move on. Or CPU does this, let's move on. We don't really talk about it, even though it really affects the industry. So we're going to talk about risk versus CISC and how that affected Intel, and building on other information that you've seen. So you need to read this. I obviously am going to be summing up the information. What are we talking about? So before we get to the failing to see, you need to understand that fundamentally processors do a certain type of thing over and over again, right? You're processing ones and zeros, and they have something known as an instruction set or a way for programmers to deal with them. Now, the instruction set is usually built by the company, and then programs, software writing programs like Visual Studios and such, then they'll take the code that you're writing and be able to put that down into the instruction set, which will actually be executed by the CPU. So what happened a long time ago, right? IBM was in this thing for a long time. They've been making processors for a long time. And back when they were really doing this, they took a look and said, hey, we've been designing these processors. Are these processors doing what we think they're doing? How is the processor really being used? So it's kind of like starting to build trucks. It's kind of like Ford Motor Company or Chevy or whatever back in the day, it would have been Ford, saying, how are our vehicles being used? And then realizing, oh, our vehicles are being used to haul things a lot. So maybe we should make a special one that is really good for hauling things, right? That same kind of concept. That's what they're doing. So they looked at it and they found out that 80% of the processor's time was spent on 20% of the smallest instructions. 80% of the time it's doing small instructions. Well, if that's the case, then maybe we should make a processor based on that. Now, this is reduced instruction set computing. That's what that stands for. So basically what it's saying is I'm going to break down my process cycles into small instructions. I'm going to accept small instructions. That's what I'm going to do. And then that should create a processor that even though the gigahertz ratings are identical, it'll be faster to do. Now, the other thing that was happening at the time, the way that Intel did things was complex instruction set computing. And that really meant I can have a very large complex instruction set and spend multiple cycles, right? So when you deal with megahertz and gigahertz, that's a cycle of how fast it's cycling. And every time it's cycling, basically you can process something, right? It's like a spinning door. So multi-cycle, CISC commands, basically would say, I'm going to use 12 cycles on this one complex command, where RISC is like, no, you're going to have to break that down into small instruction sets, and then I'll process each one of them in turn. So the biggest reason why CISC, which is Intel, right? Intel's the big dog. Intel's the one that makes everything for PCs and servers. The reason why that they got into that is because this uses less RAM. RAM was really expensive back in the day. And so if you wanted to have a RISC processor, you were going to use more RAM. In a way, you could say that the 68,000 processor that Motorola had that the Amiga and the Mac and others used was kind of more RISC-based than the Intel stuff. That meant if I wanted to have an Apple computer, I was going to need more RAM, right? That would increase the price of the system. So this was really good back in the day, right? Emphasis on hardware. I just kind of broke it down for you. Multiple instruction sizes and formats, less registers. Now registers, like what is that? Well, that's a special type of memory. That's the way you should look at it. It's like special type of memory. So you need less of that. In other words, it's going to be cheaper to make that. More addressing modes, extensive use of micro programming, and instructions take a varying amounts of time, cycle time, which I explained. And then pipelining is difficult. Now, what pipelining means, and we're just barely scratching the surface. You can go out and read all about this and become an expert in it. But pipelining is basically saying, I know what I'm doing here. And so I'm going to get this pipe going while this one is finishing. And then while this one's finishing, I'll get this one going. That way we have something in the pipe all the time. Well, that's a problem if you've got a mix of different things that are going to be coming down that pipe. Over on Risk, your emphasis is on software. So better writing of your software, the faster it's going to run. Instructions of the same set are fewer formats. So there's fewer things that it has to deal with. It does use more registers, so more special memory that's expensive. Fewer addressing modes, and then complexity in the compiler. So in the software in this compiler. And then the instructions take one cycle at a time. Boom, 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 boom. So pipelining becomes easy. I know what's coming. I know what's coming. I can process that. So we can fill up those pipelines. Right, so back in the 80s and 90s, Intel made CISC, while others made RISC like MIPS, SPARC, IBM's Power CPUs. Apple used those when they switched, and then Apple then switched to Intel's in 2005 due to the lack of CPU availability. So IBM couldn't make enough CPUs for them that were RISC-based, and so they changed their entire set of programming over to use Intel's. And we'll look at that in a minute. So during this time, there was always a debate on which was better and which would eventually dominate. As an illustration of the diversity at the time, Microsoft programmed Windows NT for, that's the predecessor to XP, to work on CISC and RISC. When I would install on the CD, the Windows NT CD, which was basically what you would want to use at work, is more secure, there was two folders. One of them was x86, which was CISC-based, and one was RISC. The other one said RISC. So you can install it on either one of those pieces of hardware way down to the CPU, and it'll work. Right? Tech journals at the time, however, had chosen their victor, which was Intel's CISC. Right? And by the end of the 90s, there was no real RISC machines around. Now, the thing is that as far as development goes, like way over there academically, they're still working on RISC, right? They still have this, like, this is a good way to do things, attitude. Maybe it can be used someplace. So when things start to go mobile, right? When they start to get mobile, which most didn't understand, Apple in 1993 produced their first handheld computer called a Newton. And it was very expensive because it was really the first of a kind, but they actually used something called ARM, an ARM processor in there, which stood for Acorn RISC machines. I wish I could find the story. You know, I need to spend time finding all these little things I talk about that I've missed over the years. But when they turned on, when they were first dealing with RISC, this Acorn RISC machine, they actually saw, you know, they tested it, it was processing, and then they turned the power off and it continued to process. And they said it continued to process for minutes, 10, 20 minutes with no power source. It was just going off of the residual power. So being able to get processing done at an extremely low rate of computer power consumption, sorry. So in 1997, Palm Corporation, Palm Pilot, they came out. It was a lot cheaper. And they didn't initially use a RISC, but pretty soon they needed the power that that chip had, and I mean processing power, and pretty soon they were. So ARM kind of continued to go around, right? The ARM came from ARM, sorry, the little history on the ARM. Needing to move from computers of the MOS 6502, remember that was basically the 8-bit computer there. They needed something else, and so British computer manufacturer Acorn Computers developed RISC in the 80s, so a long time ago. That then evolved into ARM Holdings. That's the design company, basically, and Cambridge University still got some money from that. That is the one that NVIDIA wanted to buy, basically, and got blocked, which I understand. I'm sure that Britain's biggest, largest, most successful IP creator was not going to go to a Silicon Valley company, right? There's a prime thing there. So anyway, basically what you have now, what you need to understand from this is these ARM holdings, they make this processor design, and then places like NVIDIA and all the rest of them, Qualcomm, Texas Instruments, IBM, Apple, they all basically say, okay, well, we'll license that from you, and then that they're allowed to actually modify it in some ways and then implement it into their products. And that's how ARM Holdings gets its money. It's not that they're making the processors, they're just designing them and letting other people make them. Which makes a lot of sense. So here's the thing, with 95+% of the mobile market and then 100% of the graphic markets, because basically NVIDIA and AMD are using ARM technologies, or RISC designs, I should say. It's huge. This is huge. And as you see, what I'm trying to show you is as you switch to mobile, that really truly affects the companies that have been making it, right? They really, if you want to learn more about them, you can go take a look. All right, so here is Moore's Law. So this is legitimately Moore's Law. So you hear it misquoted all the time. What Moore, right? So Gordon Moore, one of the founders of Intel, he said the number of transistors on a chip will double every 18 months. So that's been simplified, saying the power of a computer will double every 2 years, right? That's what they've simplified it to, but the real quote, the real understanding is the number of transistors on a chip, on a CPU, will double every 18 months. Well, CISC made that happen all the way through the early 2000s, but this is slowed. It really has. If somebody was to ask me, hey, I want to buy a new computer, I'd say, how old is your computer now? And so we'd look at it and go, well, if you got basically an Intel i5 that's an 8, right, 8,000 something, there's no reason for you to update. A 5 to 10% increase over 18 months is nothing, right? We looked at the numbers on the S curve. Oh, where's my double? Where's my double the power? I want that kind of improvement. No, we ended that. CISC is at the top of its S curve. We cannot use that anymore to do what we want, right? So, however, RISC is capable of doubling its processor power every 18 months. Apple announced in 2015 that its RISC ARM-based processors found in the iPad Pro was as fast as most mid-range Intel i5s found in the notebooks at the time. And that's no lie. I've got an iPad right here in this case, right there. And that thing is faster than most i7s because it's not as old as that one. That's 2015. I bought mine last year. Right, so it's really, really fantastic. Now, when I wrote this, I did not have access to this brand new information. Right, so let's look at Apple's M1. And again, the only reason I'm talking about Apple a lot is because they seem to be doing stuff. And if it was Intel doing it, I would be talking about them. Right, so here's their M1. Then they made an M1 Max and an M1 Ultra. So if we look at the M1 Pro here, let's see what we've got. We have a 10-core CPU, 33.7 billion transistors. What? 33.7 billion transistors. Immediately, if you see something like that, you should say horsepower. Now, obviously, there's a ton of other stuff that also makes horsepower work. How efficient is all the stuff you see on the screen? But if you're talking about a CPU that's got 16.7 billion, and this one's 33, yeah, that 16.7 is not keeping up with it. It's got up to 10 cores of the CPU and up to 16 cores of the GPU, but that's not all. That picture doesn't show it, and that kind of pisses me off. There's also neural engines. So we'll show you this one. This is not the same processor. See, this has got 16 billion transistors, but the newer neural engine here has 11. Let's show them some 16 cores for the neural engine. Now, if you're wondering what the heck is a neural engine and why would you even put that in there? Because man, it's all about CPUs and GPUs. Neural engine is basically saying we are ready for your AI. We know that artificial intelligence is going to be implemented, and we've actually added stuff into the core of this system, whatever system we put this in. We added in 16 cores for a neural engine. So we're ready for you, right? That tells programmers, hey, you know what? I can actually use that thing to do what I want to do. That's a huge thing. Remember when we talked about how Apple had a floppy drive and Commodore didn't, and how that changed things? We're using that same kind of attitude and basically saying, hey guys, if you want to do your AI stuff, come over here to Apple, because we got all these neural engines just waiting for you. Right? And that's going to influence development. People are going to say, I'm into AI and I can't do what I want to do on Intel. So I'm going to go over and use Apple's. That's going to happen. So this processor, as updated from this point, their M1, right? I'm not talking about the M1. I'm talking about, this is the ones that they use, that they put in their phones. The new iPad has an M1 processor in it. The foundational M1, the first one they produced, was faster than any i7 that was available. Intel then came out with an i9, and it can beat it in a notebook version if it's plugged in, right? So in other words, if I've got full access to as much power as I need, my i9 can beat the M1. And it really pissed Intel off. I mean, it's not like Apple really called them out. They just basically said, hey, this is what we can do, right? And it really pissed Intel off because they've been on that throne for a very long time. And so what you need to understand too is, and I didn't put this in, when you start looking at NVIDIA and you start looking at AMD, I always point this out to students, right? There's been a big problem with getting graphics cards. And why? Because they're being used by bit miners. Why are they being used by bit miners? Why aren't we just packing in a ton of Intel chips into those? Oh, wait a minute, because they can't do a good enough job. Yeah. Not only that, cloud computing. So if you start talking about Amazon Web Services, huge thing, right? Huge thing. Microsoft Azure, right? This cloud services that's massive that you can do all the stuff with. You can program something small or something massive. Guess what it's running on? AMD's, NVIDIA's. As a matter of fact, there's companies coming out trying to get into that market because they can see that there's this massive market for processing that kind of information. Well, where was Intel? Intel could see that happening. Why weren't they saying, hey, wait a minute, we're the server CPUs. How are they doing this? Let's see what's going on and make one better than them. Instead, basically, they just said, hey, we're going to modify our chip a little bit and make it more like all these ARMs. So we want you to know that, because now the buzz is all about them and not us. And here you go, right? And so they bring out that, it's in a notebook. I think it's in an Acer notebook that high-powered CPU is in, that beats the M1. And then, of course, Apple's not really competing with them. They are just looking at their lineup, right? So if you're buying stuff, I can't afford this stuff. But if you're buying stuff from Apple, and you say, well, I'm a home user, right? Let's look at that. I'm a home user. And so I'm going to get a MacBook Air or an iMac 24-inch or a Mac Mini, right? And then see, they have this Mac Studio, right? What they're trying to say is, are you an animator? Are you somebody that's into video? Well, then what you want is our M1 Max, not our M1. Or maybe you would go for the M1 Ultra, right? 20 cores, 48 cores, 32 neural engines. How much power do you want? And then look at what they're actually, this is a high powered machine, right? What do you mean only 32 gigs of unified memory? Yeah, because that's all we need, right? We don't need a ton of space for that. But look at the prices. I can't afford that. Nor do I need it. My wife, like I said, she went to Mac a long time ago, and so we got a MacBook Air. I think it's so fast. Runs faster than this one that is burning on my desktop, making all this noise. This is a MacBook Pro. It's got an i5 in it. So massive changes, right? S curve. When you start to see Intel's stuff and you start to go, oh, we're not getting the performance boost out of this. What's coming? What's coming? This stuff's been around since the 80s, but obviously it hit really hard once it starts to get into the phones. Now, the strange thing is, and this is just mind-numbing to me, really is just mind-numbing. Intel back in the day had this president that was, or the CEO that was just, he was really good. And he looked at things and said, you know, we really got to be ready for some of this stuff. So they went out and bought this company called StrongArm. Now, that sounds stupid, but they bought it, StrongArm. And you can tell, right? ARM processors, StrongArm, right? That's Cortex is who has that now. And so ARM Holdings, you realize, okay, that's a RISC processor that they're making. And so they buy StrongArm. And then what happened is they sold it. So this, I can't remember what happened to this CEO, but basically he ends up getting pushed out or fired or just left. I don't know. And it's not even a few years before Apple comes to them and says, we have this thing that we're doing, right? So you have to understand that Apple has switched over to Intel and has a super strong relationship with Intel that's just awesome. And we go, yeah, we need something for mobile. You guys, are you working on that stuff at all? No, we had the StrongArm company, we sold them. Oh, well, you know, battery power, we can't use one of your CPUs and it would only last like 3 seconds. So we're going to have to do something. And so they went out and used something for a while, and then they started to design their own processors. And the reason why, Intel wasn't making them. If Intel had been making this stuff, right, they would have said, you just do that, we'll focus on our stuff. But it got to a point where it's like, Intel, how can we sell a brand new MacBook for the same price as we did last year when the CPU only has 5% performance boost? Our customers are not Dell customers. They're not HP customers that are just going to go and buy it because it's a brand new one. They're going to go, what do you mean that thing's only got 5% faster? They're not buying that. And so they have this really long cycle. It was like 3 or 4 years before they would actually update a computer. And people are like, why are they waiting so long? Well, why wouldn't you? Why would you redesign things and put a new CPU in for like 5% boost, if that? Not worth it. Now, of course, right, M1, and I would imagine it's going to be on a cycle. I don't know. I don't think there'll be an M2 coming out this year. I think what they'll do is like they'll have it on a 3-year cycle. That basically we've got this super powerful processor you guys haven't even caught up to. You people are using it, haven't even caught up to it. You're not even stressing this processor out. 3 years later, okay, now it's time. Here's our M2 processor. That's what I think they're going to do. Anyway. So basically they had to choose something else, and then they had to start developing something else, which totally leaves out Intel. So Intel is the dinosaur that's being put into all the PCs and notebooks, but it's not being put into any phones. And to make matters worse, you got Google over there selling Chromebooks that are either Intel or ARM. They put them into both. They'll have them working on both. So yeah. Now, where does that leave Microsoft? Well, Microsoft has been really stupid in this whole thing. They really have tied themselves to Intel. And it's like, you know, sink or swim, both of us will go down together. That's the only thing I can see. Because as I said, Microsoft with NT had a version for RISC. But now they haven't made anything. They just keep making it for CISC. So while there's really good processors out there that Cortex and the Cortex processors, sorry, Qualcomm is making, and NVIDIA is getting into it, and other people are starting to make them, that they could use, they're just not. They just keep Windows on CISC processing, keeping that Wintel situation happening. The only thing that they've really said, and I know some of you are going to say, no, they said they were going to actually move to ARM. It's like, yeah, they said that for, I don't know how many years now. I can see them doing it on servers, right? Because of that problem that we have where we're doing all this cloud stuff and it's running on AMDs and NVIDIAs, but their stuff doesn't run on that, right? I mean, their Microsoft server stuff doesn't run on that. So I could see them switching all that over, so it will. But as far as our PCs go, I don't know. And it's really kind of weird because back in the day, right, in 2010, when iPads came out, not joking, Microsoft said, oh, we've been making tablets for a long time, which they had. They made a tablet in 2002. There was tablets before them, but they made a tablet OS in 2002, and I used it. I was all up on that stuff. And they saw it as a niche, but they really didn't understand that the processing power, the screen, the battery life, all of that was not there. And so in 2010, they bring out the iPad, and not joking, the iPad sales go like this, millions and millions of iPads. And the opposite direction is that the notebooks and PC sales go like this, down. And at the time, right, it was such a huge decline that places like Dell were like, we don't just sell PCs. We don't just sell PCs. We're solutions providers. We provide solutions too. So in other words, don't stop investing in us. It was so bad that HP actually made a tablet, and they stupidly pulled out of it because they had a really good tablet. They just needed to stick with it, right? It's just like the Xerox story, right? They brought out a tablet. That's not selling enough. Can it? You just can the project. So anyway, people just thought, oh, it's just an Apple thing. Meanwhile, they're selling millions of iPads, and they continue to sell millions of iPads. And Apple's way of viewing things, right, was changed by all that stuff that they had to go through. And lots of people think it's strange. But basically, the way they sell this stuff is I can get an M1 processor in my iPad right here. Look, I'll change my face is gone. No, it's not. Anyway, I can get a M1 processor in this, or I can get it in a notebook. And basically, I can run Mac OS on the one that's on the notebook, and I can run iPad OS on the one that's on the iPad. In other words, they're like, buy what you want. Yes, we are cannibalizing our notebook sales because notebooks are worth a lot more than an iPad. You can get an iPad, the lowest one. It's more powerful than any other tablet that's out there, and the thing will cost you like $400, right? And then this one goes up to, I just bought a notebook, right? In any case, that's how that's changed them. They just buy what you want. You know, the switch is happening. We're not going to stop it. We're not going to try to make it not happen. So get what you want to do. And so iPad sales continue to be really strong. And then Microsoft, right, they missed out on the whole thing. So back in when they made Windows 8, that was their effort to try to switch to people from desktops to tablets. So think about, if you haven't looked this up, look up Windows 8. I said this in another video, I think. Look up Windows 8 and find frustrations with Windows 8. Watch some of the videos. It's just hilarious. You basically take the start menu away. There's no way to get out of things unless you have gestures like you can swipe down on the screen, all that stuff. Basically, Windows 8 was a tablet system, and they forced as many people as they could to go from 7 to 8. And all of a sudden, people are just ticked off about it. It was this huge, heavy-handed way of, we will force you to use our stuff. We'll get you to use our Windows 8, and then the next time you want a tablet, you'll get a Windows 8 tablet. And of course, it just pissed people off a lot. All right, so anyway, to move on here, that mistake of Windows 8, they had already produced Windows RT, and that was a version of Windows that ran on ARM. What? Yeah, they produced a tablet that was the cheapest one they had, and they called it Windows RT. And people didn't want it. Like, oh, I want Intel, and they're largely business driven, right? Not home driven. And instead of sticking with it and saying, yeah, we'll just have that as an option out there. If you don't want it, you don't need to buy it. They just tanked it. And so like, oh, forget it. So you think that's back in what, 2011 that this happens? They would be so much further ahead because they would still have had all this investment in making sure this was working and upgrading it and improving it. So what does Intel do to try to combat ARM right? So you got Microsoft over there going, dude, Intel, there's no way to be running our stuff on a tablet because everybody wants your processor in there. And so, come on, what are we going to do? Oh, we'll make this Atom processor. And if you know what an Atom processor is, you know you don't want one. The problems were the price, it's more expensive. Power efficiency was worse. And how fast the CPU processes at a lower power consumption was bad. And so what that ended up with, and has right now, you can go to the Microsoft Surface lineup, which they always compare to MacBooks, which aren't. They're compared to iPads. That's what they should be compared to. And the Surface costs between $800 to $2,100. Meanwhile, over on the iPad line, you can get one for $429 to $1,900. That's, even if you're a person that's saying, I'll never buy an Apple, you have to realize that not everybody's that way. And why wouldn't I go buy one for half the price? I don't need to use Microsoft anymore. I'll go buy this one. And why is it half the price? Because I'm going to slap an Intel in this one, and it's going to cost me more. That's what it comes down to. And so Microsoft, basically, that's what they're always doing. Oh, look at our Surface, and the MacBook can't do this. And it's like, your Surface is compared to an iPad, not to a MacBook. So get that straight first, right? So they finally start shifting. They finally start announcing that we are going to make Windows 10 run across anything. They still haven't done it. They announced Windows 24 in 2014. All Windows 10 would run across anything. It'll run on anything. And they never have done that. They've never really completed it. What that would mean to me is that somewhere on the business side of things where they're not understanding what's truly at stake here, you got the golf going on with Intel, and Intel's like, you just stick with us. We're going to get this figured out. In the meantime, Microsoft is just tanking because of it. Instead of going, yeah, Intel, you get that figured out because we're going to do this. And when you come out with something that's comparable, we'll go ahead and start using it again. Right? And they haven't, they don't take that attitude. So Microsoft's greatest mistake, failure to reading the signs, what they truly were. They didn't understand that the iPhone paved the way to mobile computing. Then the iPad settled its fate. The iPad came out and it's like, wow, I can mobile compute. And now you may not understand that because you don't use an iPad. And that's a lot of times because, right, your phone was so expensive, you're not going to buy a tablet, you'll buy a notebook instead. I do everything on my iPad. The only thing I don't do is this video because on Zoom, the Zoom app doesn't actually show my picture on the screen. I could do this, but I wouldn't be here. And I know I'm pretty, no, I'm joking. So anyway, they don't understand that they are losing the server market because they're relying on Intel, which is not being compatible in server CPUs. And they're losing the desktop market because that desktop market is disappearing and shrinking, and it's moving to tablet computers and to mobile things, mobile devices. And people go, I don't think so, you know, because I like whatever. You like what you like mostly because that's what you were raised with. I still use Excel, man. I still use Excel. Why? Because I know that thing in and out. And even though numbers is truly powerful and does so many things easier, it's a hassle. I don't want to use it. Google Sheets, no, right? I know how to use Excel, I have access to it. There's no reason for me to switch. Kid growing up, they only need this. That's all they need. As long as they have that phone, they can compute. The next step for them then is, I want the same thing, right? I have a tablet. I want the same experience on a bigger screen. And so we can't expect, you should expect that those that come up younger than you are going to be shifting that market. And they're like, why do I need that? I don't need a notebook. Can I not have a notebook? Give me a tablet, you know, and if they're used to Android, give me an Android tablet. If they're used to iOS, give me an iPad. I don't need your notebook, right? So Microsoft's got the shrinking market. And unless they do something and get away from Intel, because Intel is just doing very little to actually catch up And I do believe Intel has a chance to catch up. They are very smart, but I just don't know why they haven't been trying to do this all along. Right? It's McBride teaches classes. He's not the only one in the world that has started to see that shift and started to see it years ago, started to see that S curve flatten out. Intel should have known that. But as we learned from past history of things, Apple should have known things and not pushed the Mac. They should have just pushed their Apple II lineup and transitioned people, right? IBM should have stopped trying to fight Microsoft on everything that they did and realized that they were going to have to lose some of that market in order to stay afloat. Commodore should have understood that we can't lose Jack Tramiel because he's the one that's had these philosophies that's pushed this thing and made it successful. But pride in people tends to make that not happen. You think, we really don't need you. We'll get rid of you and we'll be just fine. So that is failing to see. Intel failing to see that back when they had strong arm, they should have just kept working with it and just been, because who cares, right? They're just being used in these little things. It's no big deal. And realizing those little things are going to start taking over because they will become more functional. And how do we know that? Well, we had these PC things, right, that we shoved our processors in, and they were pretty limited to begin with. And over the years, they've improved. Wouldn't that hold true for the mobile ones too? Yeah, shouldn't have taken that much, but they didn't get it. Well, if you got questions or comments, let me know. Have a great day. We'll see you later.